My presentation is 3D printing triumphs through the eyes of the small and mid-sized enterprise. Let me start off by asking, how many small and mid-sized businesses do we have in the office? Please raise your hands and keep them raised. Oh my goodness. How many business units of large corporations, keep your hands raised, the first group, that act as a small and mid-sized business do we have? It's not as many as I thought. Well, for you, I have something. For the others, I hope I have some information for you to take home, because I am going to be talking specifically to the small and mid-sized enterprise. Now, I'm guessing you're here at TCT to find the latest technology, to find the latest applications, to find the big ideas. Well, guess what? I'm not going to cover that. The triumphs I'm talking about today are more pragmatic solutions. I fear that the headlines that we receive now, the information that we have, is so slanted towards production and big companies and big names to get all that excitement and the coverage, to get us all interested, that it's skewing our view of the world. So my goal is to readjust the thinking and hopefully to give the small and mid-sized enterprise comfort in doing what is practical, what is right, so that you can plan for and act on the future. So the crux of this presentation, first one is a philosophy, a belief, and then I've got the two messages I'd like to cover. The crux is the small and mid-sized enterprise is different than the big businesses that are typically covered in the news. We hear about GE, GE Avio, BAE, NASA, Airbus. We hear all those names, but I find that many of the small and mid-sized enterprises react to those stories with one of two emotions. And one is, yeah, but. Fantastic story, but I'm not like GE. I don't have the resources, financial and human. I don't have the time horizon to invest 10 years to get to that future. That's not me, so we tend to shut down. Or, even worse, we believe that it's true, it's real, and it's a drop-in solution today, and we go off on this unrealistic journey, shooting for the stars, when we should be keeping our attention focused here on Earth to navigate the forest that stands before us. To navigate the forest and also deal with those forest fires that invariably crop up. Now, large corporations have a forest to navigate. They've got a roadmap to create, and they have forest fires to put out every single day. It just so happens that they tend to have teams that do one thing, the tactical, and teams that do the other, the long-term strategy, as John indicated in the presentation from BAE. So a fundamental difference. You as a small and mid-sized enterprise have real needs, practical needs, things that need to be done today with a limited set of resources. And that's what I want to go after. So with this, with the yeah buts and unrealistic expectations, I want to make you more comfortable in tackling the mundane. There are substantial gains in doing the mundane, boring applications that we've been doing in additive manufacturing or rapid prototyping for the last 24 years. I want to refocus you on the mundane, and I also want to give you comfort that doing that is acceptable and it's a strong value proposition for your company. The other element of my message is you've got to reach this delicate balancing act. You must act for today, and that's in the mundane, the boring applications, the ones that have absolutely zero sex appeal, so they're never ever going to see a headline. But at the same time, you have to be planning for that future. That could be a future that's 6 months, 1 year, 5 years, 10 years out, but you have to do both. And I believe by doing the mundane today, gaining wins that are practical tomorrow or next week, that gives you a foundation upon which to build to then execute on those long-term, big vision, strategic initiatives. So with that, what do I mean by the mundane and the boring? Give you an example. Now, first, disclosure. I am affiliated with this company, ArcMim. I'm not doing this to promote that company. I'm doing this because I witnessed the application firsthand, and it rung true in my heart, and I celebrated it. ArcMim does metal injection molding. If you're not familiar with the process, you injection mold a combination of metal powders, wax, and polymer. It then is fired or sintered to burn away the wax, the polymer, and sinter the metal. During that process, you have 25% shrink, upwards of 25% shrink, yet they're hitting sub-millimeter tolerances. Part of that success is the art of designing a ceramic tray to nest the green body part while it's being heated in the furnace, to guide it, to gently coax it into the end result that you want, high precision. The old way of doing things, use knowledge, experience, and intuition and say, I believe this configuration of a cavity will be the best solution. They would then have that machined. That would then be, cast rubber would be put against that. That rubber would be used to cast a ceramic tray, which would then be test fired. When it didn't work, invariably it didn't work, they go back to a redesign based on what they learned, do another iteration, and they were spending $2,000 to $3,000 a throw on the machining, and 2 weeks. It was all in series. But a young engineer stepped up, didn't know any better, changed the game and said, you know what? I can 3D print a pattern. I can do it for a couple $100 and I can do it in 2 days. But he took it farther. He said, I can put 25 different configurations in that same pattern. So when we do the ceramic and have our testing, we now have 25 test conditions in under a week for a couple $100, and that changed the business, that accelerated the ability to deliver. That's what I mean by a mundane story. We've been doing patterns for 2.5 decades. You will not read a headline about this company doing a pattern because it is boring, it's mundane, but there is huge gains. Well, there's substantial gains, I should say. Maybe not huge, but substantial gains. And I want to give you the comfort to tackle these, to tackle the practical solutions of today while you're planning for tomorrow. Now, the other extreme, what's not mundane, is that focus on production. I really feel that so many of the stories today are all about series production, series production, series production, series production, and causing many of us to take our eyes off of the ball of what we can benefit from today. And that's where this message is coming from. Another reason I want to talk to the practical mundane solutions is the dispersion or distribution of applications. This is one of the equipment manufacturers' data. I'm not going to name them because I don't want to have you mentally going, oh, well, they're different than others. I want to get it out there and just represent it as a general positioning of this entire industry. For the product development applications, 70% of this vendor's users are using the technology for product development. Concept models, patterns, functional prototypes, maybe some test pieces. That's the mundane, that's the boring. But 70% of the use is still going into that. For you to be focusing on production and going for this long-term big win without having the boring applications today, the easy wins, I think is a bit myopic and possibly dangerous. The other thing on this data is 30% are doing manufacturing, but only 15% are doing manufacturing of series production parts. The other 15% that was labeled manufacturing is in another mundane application. Jigs, fixtures, trays, work holders, end-of-arm tooling for industrial robots. And that is an area that I'd really encourage you to focus on. It's boring, it's mundane, it's low risk, you've got rewards, it's also easy to, if you have a setback, it's easy to reset and retry something else with very little penalty because we don't have any assets involved with 3D printing. So there, I really, and I've got examples of this, I'd really recommend that you go back to the office, take a look at doing more jigs, fixtures, other manufacturing aids, because if I polled each one of you separately, I bet you would say on our production floor, yeah, we need more jigs and fixtures and other things to expedite production, improve quality, and we just don't have them because we don't have the time, we don't have the resources. Well, make the time, make the resources with this mundane win. But production does not have to be an out there thing. Production applications of additive manufacturing can also be boring and mundane. Here's a little company out of Canada, Lowen Window Manufacturer. Anybody even heard the name? I never heard them. Saw a young gentleman present at a conference in Canada, and this is another story that just had me saying, yes, they get it. The boring application is corner keys. These go into the corners of their windows. The extrusions that form the frame mount on these corner keys. For custom windows, odd sizes, they were milling each one of the corner keys. Once again, this young engineer says, I got a better way. He designs them, he 3D prints them, they've got the solution the next day. And they've used that for a number of years, and they actually use it now as a transition until they get to high enough volume on their production windows. It is production, but it is boring because it's low risk. It's not huge reward. We're not flying on it. We're not saving $1.2 billion in fuel. It's boring. It's not going to get the headlines. But there is a win there. Another application for these guys, a control box for some of their windows. The handle often breaks. Now, there are no replacement handles anymore, so their option is to spend a couple $100 on a sub-assembly and completely replace a sub-assembly. They had an open enough mind to look for the small win and say, I'll 3D print the handles and give them to the field engineers. Another example of production becoming a boring, mundane application where you have wins today is from a company called Southwest Energy. They don't make energy development equipment. They're not even engineering and manufacturing. They are a blasting company. They drill the holes for mining. They put the charges in. They detonate the charges. Here's a company that has no design engineering, no manufacturing, but they're doing production applications in a mundane, boring way for a grappler. The challenge was they have about 5 cm diameter holes, 20 meters deep with a charge. And there's mounds of dirt around each one from the drilling operation. If a truck drives by, knocks some dirt in, they've now covered the charge. What they do then is put ANFO in, detonate that, hope that that detonates the original explosive, but then everything idles because now they got to go excavate and make sure that the charge has detonated. Well, one gentleman on the business side, believe it or not, said there's got to be a better way. Went looking for a commercial solution for a grappler. Couldn't find one. Saw YouTube videos of barges with a grapple coming down and picking up material, and he said, we can do that. They prototyped it, redesigned it, prototyped it, redesigned it, and now each one of their crews are outfitted with this. Mundane, they're not selling it to their clients. That's part of what makes it a more boring application and not a high-risk, high-value proposition, but instead an easy solution. Those are the kind of things I want to encourage you to look at when you go back to the office. Back to low-end manufacturing. That same young engineer started deploying tons and tons of fixtures throughout their operations that were 3D printed. One example here is for their field engineers. A legacy part. When it fails, the replacement part no longer fits. And in the sash of the window, the field engineer, field service person has to route a new channel. Hey, we'll just design a routing template. We'll 3D print it, and we'll give one to each one of our field engineers. Now, they took some liberty with the freedom of design concept. The spiderweb pattern there is not functional. It's purely for pizzazz to give their field engineers a little sense of, I'm different. Back to ArcMim. End effectors for robots. We have 29 injection molding presses creating the green bodies. Every one of those is paired with an industrial robot to do pick and place. Old days, until recently, all those end effectors were machined. Machined metal, then with actuators and springs and valves. And the same young engineer came up with that idea for the tray, said, you know what, we can 3D print most of the structure of those end effectors and then put the actuators on there. And by the way, we can create internal channels for the vacuum or hydraulic actuation. A lot of resistance here because, oh, no. We need to machine these out of metal. They've got to be durable. They've got to last forever. Luckily, there was a champion, and this is another key point. You need champions to take the 3D printing baton or flag and wave it and shout that we can do it. The champion said, you know what? I think you're right. And they thought it through, and they said, well, a plastic end effector is going to have a shorter life. But it's 1/5 the cost. We can do 5 of those before we exceed the cost of a machine one, and we usually end up having changes in design, changes in production schedules that cause us to change our end effectors. The other thing they stumbled on is a plastic end effector, if you misprogram your robot and it crashes, will give. It acts as a shock absorber. So they're actually less likely to damage a tool and less likely to damage the robot with a 3D printing application. Now, how many headlines have you read about end effectors for industrial robots? Probably none. Unless you're at a conference with people that are users, you probably don't hear these stories, but these are the ones I get excited about. These are the ones I get encouraged about because the small and mid-sized enterprise can do them today. I want to stop here. So now, back to the product development phase with design, the most boring and the most mundane. Before I get to ATI, there was a company in aerospace who believe that they are way behind because everyone is doing 3D printed metal of production parts. And I suspect that some of you in the audience originally had that perception before you walked in these rooms and heard BAE talk. But they had that perception when they realized it wasn't going to be appropriate for them to do production. They're like, okay, well, what could we do? One thing on the manufacturing tool side, they decided that they could use it for manufacturing engineering to dial in all the production processes while they're waiting for their castings. Instead of waiting 32 weeks for a casting to come in, and then doing all the dialing in of machining, workpiece handling, et cetera, out to inspection. They're doing all that with a 3D printed metal part that behaves the same way, getting everything dialed in and saving weeks on the back end. On engineering, they're actually prototyping the manifolds, the holes, the channels, or considering doing it, they're not doing it yet, in a faster, more expedient way to test new designs for pressure drops. Because these things are still designed for casting and machining, they're still blocky and heavy, bad 3D printed metal parts, too expensive, too time consuming, not much value. But they opened their mind a little bit and said, you know what? All we need is the channel. So let's just have prototypes that have this network of channels and no mass around them other than enough material to give me resistance to the pressure, and we'll do testing. Now back to ATI. This company focuses heavy on the aerospace and automotive industries. Its first application was to fix a problem with an electrical housing. The electronics were being fried. Too much heat. So they're challenged with coming up with a new design, but the package size had to stay the same, lots of constraints. And this is a company that is really heavy with software technology, lots of analysis and optimization tools, and they went at it and came up with 40 different designs with an open mind. They used additive manufacturing in metals to prototype and test those designs. Ultimately, they ended up with designs that can't be manufactured any other way, and the product is being manufactured through additive manufacturing. So this is a story of the mundane and also the exciting and pushing the envelope applications. But back to the mundane, with ATI, they had an impeller application. Had to redesign an impeller. They came up with 7 different designs. The neat thing, like the ArcMim story that I started with, they were able to print all of them in one run of a 3D printer in metal, allowed them to test them all in one batch, allowed them to get the most efficient design. What they told me is if they'd gone through the traditional route of taking their designs and having a machine, they would have done them one at a time in series, test, see what the results were, do the next one, test, see what the results were. After about 3 or 4, if history proved out, they would have stopped because they would have hit a point of diminishing returns. Not worth additional investment of time and money to eke out another 1 or 2%. The big win here for them, by doing all 7 at one time, very little additional cost, no additional time, they were able to find that marginal gain by the most optimum design. So triumphs in 3D printing, but triumphs through the small wins that can happen on a daily basis. 2 other key messages I want to leave you with before I hit the conclusion are necessity and luck. We all need it, the big corporations need it, as do we as small and mid-sized enterprises. A quote from Seneca, I absolutely believe this: luck is when preparation meets opportunity. Reinterpret that per the message I just gave you. The preparation or executing tomorrow when you get back, the small mundane wins. They become your springboard, your launch platform to understand the technology, its capabilities, its limitations, and create new ideas about how much farther you can push it, so that the day the opportunity arises or a challenge arises, you can say, I can solve that with additive manufacturing, because you have that baseline, you have that knowledge. And opportunity and challenges will arise. Necessity, as Plato said, is the mother of invention. I believe this too. And you'll find that necessity will happen. You will find that many of your best applications happen out of necessity. And don't give too much credit to those big corporations. Story from many years ago. The first company to publicly state that they're putting 3D printed parts on military aircraft was Rocketdyne out of the United States. Shortly after the announcement, I met one of the gentlemen and I congratulated him on the forward thinking that they had to take a prototyping technology and turn it into a production technology, and the man chuckled. I said, did I say something funny? Do I have something in my teeth? He said, no. He said, it wasn't foresight, it was necessity. Their program was going haywire. Their only option was absolute failure or to try to make 3D printing work to have a chance of succeeding, and they did. A recent story, I just learned this one 2 weeks ago. Anybody see in the news that Avio, GE Avio, is going to be 3D printing turbine blades for the low pressure compressor section of a jet engine? The story reads as if they had this foresight and they're going to use 3D printing and this grand new enabling technology and move forward. But the real story is they had a necessity to look at 3D printing, because what they really wanted is to have the blades made out of material called titanium aluminide. And as I came to understand in the conversations 2 weeks ago, titanium aluminide does not process very well in traditional manufacturing methods. It does not behave properly, so they are forced out of necessity to try additive manufacturing to see if it could counter the negative effects of the way titanium aluminide wants to react, and they were successful. So the message there is, relish those opportunities where your back is against the wall and build off of the opportunities where you've had those small, mundane, boring wins, and you have enough background, you have enough information and preparation to turn everything into luck. And in conclusion, I am not telling you to not shoot for the stars. I'm not telling you to stop dreaming big. I'm not telling you to stop building plans for doing full-blown production or doing something absolutely outlandish. I'm just trying to remind you and make you feel comfortable when you go back to capitalize on all those small wins. Capitalize on those while you're building the grand plans. And it's not out of the question. If you want to be innovative and change the world, you can do it. Jordan mentioned Local Motors, 3D printed a car 2.5 weeks ago at IMTS. It's in their DNA to be disruptive. They are about micro-manufacturing and crowdsourcing the design to disrupt the automotive marketplace. And they're using the technology. So if you choose to, if that's your corporate culture, more power to you. But I suspect that most of us are a bit more reserved, or our businesses are a bit more reserved. From our past, Align Technologies with Invisalign, the orthodontics, the clear braces, clear aligners, they also had a vision to disrupt an industry. They had an idea, and then they found 3D printing to be the enabling technology that allowed them to execute on their idea. So it's certainly possible, and I don't want to rain on anyone's grand plans. I just want to remind you that we have to take small steps. One small step at a time can yield significant advances for our companies. In this case, with this image, I hope you all recognize it, for mankind. My father told me once, he recognized that I'm a bit of a perfectionist, and I sit down with pad and paper. Yes, I'm old school, not tablet. Pad and paper, and I come up with very detailed, elaborate plans, never acting on them. Kind of, oh, what's the phrase about perfection getting in the way of actually doing anything? But he saw that in me, and he said, son, he actually sat me down, put his hand on my shoulder, and said, son, on the way to the perfect crime, you've got to rob a few petrol stations. Now, Dad's doing 10 years to 15 years in the state pen, but his message still rings true. And that's the message I want to leave you with. Have the grand plans, but make sure you're taking care of business today. And do not feel guilty. Do not feel that you're not doing enough if you're doing the mundane things with 3D printing. That is the key to success. That is the way I believe to operate as a small and mid-sized enterprise. It's an enabling technology, it's a fantastic technology, it can allow us to do amazing things, but at the same time, look for those ordinary, routine things, and just look at the world a bit different, and look at 3D printing as an opportunity for you to solve a problem or capitalize on an opportunity. Wish you all the best of luck in your journeys with 3D printing. Thank you.